Okay, this is the second video on the practice test, Unit 6, because the first video is getting long. Anyway, let's move on. We have question number 10. It says to find the, well, first of all, let's pretend we didn't see that answer, okay? It says find the summation from 1 to infinity, so it's an infinite series. And the question is, do we have an infinite arithmetic, which would simply be infinity, or do we have an infinite geometric, which we'd have to use a formula if r is less than 1. And in this case, we know it's geometric because it has a common ratio, 3/5, and because the absolute value of your common ratio is less than 1, then you know it is convergent. It is a decay function that decays to a certain asymptote value, which means that you will have an answer. So because this r, 3/5, is less than 1, you're going to be able to get an answer. So we are going to use the formula. And the formula is S sub n equals, simple, a fraction. A sub 1 is up on top, 1 minus r on the bottom. It truly is the easiest formula to use. So what is a sub 1? We're going to simply plug in 1 right up here. 1 take away 1 is 0. Anything to the 0 power is 1, and 1 times 16 is 16. So with that said, I know that a sub 1 is 16. And again, what is the common ratio? The common ratio is 3/5, and that's all we need. Let's just plug it right in. The summation of however many numbers, actually, it's not however many numbers. Let's be 100% correct here. It's actually an infinite amount of numbers. So we could put an infinity. That is an ugly infinity. Let me try that one more time. We could put an infinity right here, and even up here. That's an ugly infinity. Anyway, here we go. A sub 1 is 16. On the bottom, we have 1 minus 3/5. Again, the trick that I always tell you to use is to change this 1 to become a 5/5. Whatever the denominator is over here, make that same denominator up here and down there. Okay, because 5/5 is a 1. If it were a 7, you'd have a 7/7, which is a 1. If it were a 2, it'd be a 2 halves, which would be a 1. Anyway, now that we have 5/5 take away 3/5, so now that we have a common denominator, we could say 5 take away 3, which is 2. Final answer is 2/5 in the denominator. So we have a 2/5 in the denominator. So what do we really have? We have 16 divided by 2/5, which is the same thing as 16 times 5 halves, which you could multiply the top with the top and get 80, bottom with the bottom and get 2. 80 divided by 2 is 40. Or you could have also said, you know what, I want to cancel the 16 with the 2. 16 divided by 2 is 8, and 8 times 5 is the same answer, 40. So your answer to this problem is 40, okay? Even though it's infinite, the answer is 40. On this one, they're asking us to find the sum of the above infinite series. ... means that it continues forever if it exists. Now, what does that mean? It all depends on your common ratio. Once again, if the absolute value of your common ratio is less than 1, it's going to be like a decay function, which is convergent, which means that it'll actually have an actual answer. If r is greater than 1, it's going to grow forever, which the answer would be infinity. So you could easily see that it's not growing. From 108 to 81, it's getting smaller, right? But let's be on the safe side and actually calculate what that r is. So on a calculator, I'm going to do 243 divided by 4, I'm sorry, divided by the previous number, 81, okay? So I'm going to do that fraction divided by the previous number, 81. So I'm going to do that on a calculator, and when I do this on a calculator, it's probably safer to put the 243 over 4 in parentheses, okay? So use parentheses. That's what I want to do. Parenthesis, 243, close parenthesis. Oh no, I'm sorry. 243 divided by 4, close parenthesis. You could even hit equal and then divided by 81, which will give you the answer 0.75. 0.75. So we know that r is 0.75, which is definitely less than 1, which means I will have to use a formula, right? You could use the decimal, or you could use the fraction 75 hundredths, which is the same thing as 3/4. So you could use a fraction 3/4, or you could use a decimal. Maybe on this one, since we have been using fractions, I'm going to use the decimal. Let's try using the decimal. Anyway, the formula for this infinite geometric series is s sub infinity equals a sub 1 divided by 1 minus that common ratio r. And again, if the ratio would have been greater than 1, if it would have been like a 1.25, the answer would simply be infinity. And that's what the instructions say right here. It says, if it goes to infinity, just type in infinity. Okay, let's go back over here. So let's plug in our a sub 1 value. A sub 1 is 108. A sub 1 is 108. So I really have a 108 divided by 1 minus r. And I said I'm going to use a decimal this time, so I'm going to leave it as 0.75. So on a calculator, if you go 108 divided by, if you actually went 1 minus 0.75, $1 take away 75 cents, that'll be 25 cents left. You could put a 0 if you want, you don't have to. And on a calculator, if you go 108 divided by 0.25, you get your answer 432. Okie dokie, let's move on to the next question. So right here we have another series. Question is it arithmetic or geometric? Obviously we have the base with the power, so this is geometric, and the common ratio here is 3/2. So you might as well write that down. R equals 3/2. Now, don't make the mistake that I made on a previous video where you do the summation of an infinite geometric series where you have a sub 1 over 1 minus r, and you actually plug in this r right there. Now remember, if your r is greater than 1, from one term to the next, it's going to grow, and you're going to be infinitely adding bigger numbers and bigger numbers and bigger numbers, so you already know that the answer is going to be infinity. If you actually use this formula and plug it in, it's going to be wrong. It's going to be wrong. So do not use the formula. No, don't do it. Okay? Just because r is greater than 1. If the absolute value of r is less than 1, then that's when you use the formula. Use formula. But if the absolute value of r is greater than or equal to 1, it's gonna grow. That's so bad, me using the word gonna. It's gonna grow forever. Okay? So the answer is infinity. Okay? And if we look at our answers right here, there it is, infinity. I want you to actually type in the word infinity. If you don't use all caps, it's okay. If you use all caps with the period, it's okay. If you don't use all caps with the period, it's okay, right? So all these, just type in the word infinity and you'll be good. I love these questions. They're so easy. Anyway, moving on. They want us to find the sum of the infinite geometric series given this information, and that's pretty easy because the summation formula for an infinite geometric series, and I shouldn't even put s sub n. Why do I keep doing that? That should be s sub infinity, technically, is going to be a sub 1 over 1 minus a common ratio r. So they're giving us the a sub 1 term, which is 15. So you have 15 up here. And on the bottom we have 1 minus the common ratio r, which is 2/7. Now, if this would have been a 7/2, then that'd be greater than 1, then you would say your answer is infinity. But because it's less than 1, then you know you could actually use the formula. And again, the trick to using this formula is to change the 1 to whatever this denominator is, both on top and bottom. So I'm going to change the 1 to a 7/7. Okay, so I could cross out the 1, scratch it out. So now you really do have 7/7, take away 2/7. Because you have a common denominator, you could do 7 take away 2, which would be 5/7. So what you really have is 15 up on top over 5/7 on the bottom. That's 15 divided by 5/7, which is the same thing as 15 times 7/5. And you could cancel the 15 with the 3, or with the 15 with the 5, leaving you a 3, right? Or you can multiply top with the top, bottom with the bottom, and then divide. But I think it's easier to say 15 divided by 5 is 3 up on top. 7 times 3 is 21. Final answer, 21. Nice. Moving on. True or false? Okay, so is this divergent? Yes, it is. How do you know? Because the common ratio is greater than 1. Okay, so because this common ratio is greater than 1, 5/4, it's 1.2, I believe. It's greater than 1. That's divergent. If you're going to keep adding something that's a bigger number and a bigger number and a bigger number, because this value that's greater than 1 is going to make it grow. So that is divergent. The answer is immediately infinity. So yes, that's a true statement. This is divergent. If that would have been a 4/5, nope, that'd be convergent, right? Anyway, how about this next one? Convergent geometric series will have no sum. That's false. It does not approach infinity. If you have a geometric series, that means that the r is less than 1. That would mean that it converges to a certain asymptote value, which will be an actual answer. So this is false. Absolutely false. Because convergent geometric series will have a sum. It'd be a specific number. You would use a formula to find that specific answer. It's not infinity. Wrong. Okay. Obviously, none of these correct is wrong because the first one we did was correct. Over here, a divergent infinite geometric series will have your common ratio to be greater than 1. A divergent, that means that it goes off to infinity, and that does make sense because the common ratio is greater than 1. If it is greater than 1, it's going to go to infinity. Technically, that should be is greater than or equal to 1. That'll go to infinity. So this will be fixed on your practice test. I apologize for that. Greater than or equal to 1, it does go to infinity. So that is a true statement. And the last one, you can use this formula on all infinite geometric series. That is definitely false because you can't use it on all of them. Like this one right here, the common ratio is greater than 1. You cannot use this formula on this guy right here because if it's greater than 1, it's going to go to infinity. It's not going to be a specific answer. This only works if your absolute value of r is less than 1. So this is definitely false. So the only two that are correct are this one and this one up here. And I'll fix that typo on your practice test. Right here we have a series that starts by inputting the number 4 and stops by inputting the number 11. So your first number, you get it by plugging in 4, doing the math. Last number, you get it by plugging in 11, doing the math. And we also could identify the common ratio here is r equals -3. Okay, so the common ratio, r equals -3, that's important information. If this were to start with the number 1, then this would be your a sub 1 term, right? Let's think about the a sub nth rule for a geometric series, or sequence. A sub n equals a sub 1 times the common ratio r to the n minus 1 power. So if it were to start at 1, then this would be your first term, but they want you to actually start with the number 4. So let's actually find our first number by plugging in the number 4 right into the k spot. So let me rewrite everything. So all I did was replace the 4 right there where the k is at. So 4 minus 1 is 3. So what we really have here is a -1/9 times 3 to the 3rd. And we all should know 3 times 3 times 3 is 27. So we really have that 27 times -1/9. So when you multiply it through, you're going to get -27 over 9. And -27 over 9 is -3. So the first number is -3. Okay, so we have the first number, that's important. We know the common ratio is -3, that's also important. And I guess the best thing to do right now would be to write down the actual formula so we could see what we actually need. All right, so let's go to the formula. You could use a sub 1 minus a sub n, your first number minus your last number, times that common ratio r, divided by 1 minus that common ratio r. Or you could use a sub 1, your first number minus your first number, times that common ratio r to the n power. Okay, so it's up to you. We could use the first one or the second one, depending on which one you want to use. I'm going to go for the second one this time. Okay, so the second one is a sub 1, which we know our first term in this case is -3. So I'm going to put a -3. And then we have minus a sub 1 again, that's -3, times the common ratio. Common ratio happens to be negative 3 as well, to the n power. To the n power. Now the question is, how many numbers do we actually have? That's where you do that trick, 11 take away 4 plus 1. So that's really 11 take away 4, which is 7, and then plus 1, that would be 8. So I could find out the n by doing the 11 take away 4 plus 1, which is 8. So n equals 8. So I'm going to put an 8 right here where the n is at. So it's to the power of 8. Now maybe the first formula would have been nicer. Anyways, it's divided by 1 minus the common ratio, which happens to be negative 3. Okay. So we're going to change the minus to plus plus, change the minus to plus plus, and let's do the math. On the denominator, it's pretty simple. It's 4, right? 1 plus 3 is 4. But up on top, we do exponents first. So on a calculator, I'm going to do negative 3 to the 8th power. Negative 3 in parentheses, caret 8. That's going to give us 6,561. So this value is 6,561. And then we still need to multiply it by 3. So since it's on my calculator, I'm just going to hit times 3. And that'll give me 19,683. All right, so my new problem is negative 3 plus 19,683. So that will be 19,680 over 4. So on a calculator, we're going to get divided by 4 is going to be 4,920. So your final answer equals 4,920. There is your answer. Let's move on to the next question. So right here we have a binomial to the 5th power, and one option is to actually write it out, x plus 3 times x plus 3 times x plus 3 5 times, and then distribute, and then it's just a crazy amount of work. So the reason why I wrote this problem down here is because we need space to show Pascal's triangle, and you want to go all the way down to the 5th power. Okay, so let's go back and show you how to do Pascal's triangle. What you're going to do is do a triangle of ones. Okay, you put 1, 1, 1. And then you add 1 plus 1, the answer is 2. But then again, you put ones on the outside again. So right here you have 1, 2, 1, and then you add 1 plus 2, and you're going to get 3. And add 1 plus 2 or 2 plus 1 over here, and you're also going to get 3. And of course, bring down the ones again. And then you add the 1 plus 3, and you're going to get 4. And then you're going to add the 3 plus 3, and you're going to get 6. And then you're going to add the 3 plus 1, and you're going to get 4 again. And then you're going to add ones on the outside again. And you continue this method till you get to your 5th power. So what do we have here? You begin with the power of 0. Anything to the power of 0 is 1. Power of 1, you're going to have that row. Power of 2, you're going to have that row. Power of 3, that row. 4, that row. So we need one more. So finally, on the 5th row, we're going to have 1 plus 4 is 5. 4 plus 6 is 10. And again, I went 1 plus 4 gave me 5. 4 plus 6 gave me 10. 6 plus 4 gave me 10 again. And 4 plus 1 gives me 5. And of course, put the ones on the outside again. And here's your 5th row. So from here, we need to take these numbers and put 2 sets of parentheses between each of them with an addition, adding them all up. So that's what I'm going to do here. I know this is getting kind of ugly. But in addition to that, what we need to do is think about the power of 5. So we're going to start with the power of 5 on the first parenthesis, and that would make the second parenthesis a 0. And then the 5 drops to a 4, and the 0 goes up to a 1. Then the 4 drops down to a 3, the 1 goes up to a 2, the 3 drops down to a 2, and the 2 goes up to a 3. The 2 drops down to a 1, the 3 goes up to a 4, and the 1 goes down to a 0, and the 4 goes up to a 5. So it pretty much goes where this one was a 5, this one was 0. This one gets subtracted 1, this one gets added 1, becomes 4, 1. Subtracted 1, added 1 becomes 3, 2. Subtracted 1, added 1 becomes 2, 3, and so on until you go all the way through. Now let's be specific here. We need to put the x in the first parenthesis and a 3 in the second parenthesis. So we're going to put the x in the first parenthesis, x, 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 and we're going to put a 3 on the second parenthesis, 3, 3, 3, 3, 3, 3, and they are specifically asking for only the 5th term, okay, only the 5th term. So remember, terms are what's separated by addition. So here's your first term, second term. Okay, so here's first term, second term, third term, fourth term. This is the one we want right here, this term right here. So let's actually do this. What is positive 5 times x to the 1? That's just positive 5 times x. That is 5x, okay? And now we need to multiply it by 3 to the 4th, okay? Because we have 3 to the 4th there. So I need to multiply by 3 to the 4th, but instead of writing 3 to the 4th, I might as well do 3 to the 4th power on a calculator, and that's going to be 81. So I actually need to multiply 5 times 81 and then put an x on the answer. And 5 times 81 on a calculator, that's 405. So my final answer is 405 with an x. Now, if they actually said write the whole polynomial answer, then you'd have to do all that math to all of these and write them as a long, nasty polynomial. But they're only asking for the 5th one, so that's the answer, 405x, okay? And that is the answer they give us right here. So we need to find the 4th term of this expanded polynomial. Once again, we're going to use the Pascal's triangle, and we got to get to the 5th power, so it's going to take a while. Here we go. How do we do Pascal's triangle? You do a triangle of 1s, and then you simply add 1 plus 1, that's 2. So you're going to have a 2 right here, and then you put 1s on the outside. And then, of course, 1 plus 2 is 3. So you put a 3 right there and a 3 right there, and again, you put 1s on the outside. And then you add the 1 plus 3, that'll be a 4. You add the 3 plus 3, that'll be a 6. You add the 1 plus 3, that'll be a 4 again. And of course, you put 1s on the outside again. And then you add the 1 plus 4 is 5, 4 plus 6 is 10, 6 plus 4 is 10, 4 plus 1 is 5, and again, 1s on the outside. And of course, this is the 0 power. The power of 0, anything to the power of 0 is 1. The power of 1 is that. The power of 2 is that. Power of 3 is that. 4, and we are at the power of 5, and that's what they're asking for, the 5th power of this binomial, expanded to the 5th power, that is. And what we must remember is that these numbers are the coefficients in front of 2 sets of parentheses. So you have 1, 2 sets of parentheses, plus 5, 2 sets of parentheses, and so on and so on. Let me write that down. And of course, we also need to put the powers in here. So if we had the power of 5, we have the power of 5, so we're going to put the power of 5 on the first parenthesis. And of course, that would make that a 0. 5 plus 0 is still 5. But then the 5 drops down to a 4 on the next one. And the 0 goes up to a 1 on the next one. Okay, so what we're ultimately doing is subtracting 1 from here, adding 1 from there to get to here. So we're going to subtract 4, add 1. Subtract 1, add 1. So that's become a 3 and a 2 right here, 3 and a 2. So if it confuses you to do both of them at the same time, you might want to go just with the first parenthesis 5, first parenthesis 4, first parenthesis 3, first parenthesis 2, first parenthesis 1, first parenthesis 0. Okay, you might want to do that. And then go to the second parenthesis. It started with 0, goes up to 1, increases to 2, increases to 3, so let me put a 3 right here, increases to 4, increases to 5. And now all we have to do is fill in the values inside the parentheses. So the first parenthesis is going to have this first value of a, and the second parenthesis is going to have this value of negative 2b, negative 2b. So a on the first one, negative 2b on the second. And finally, they are asking for the 4th term. So that would be, this is your first term plus your second term plus your third term plus your 4th term. So your 4th term will be whatever we get right here. Okay, so let's focus in on this highlighted part, and we're going to do this math. And doing this math, you're going to, of course, work on negative 2b to the third. That's really negative 2b times negative 2b times negative 2b, which will be a negative 8b to the third. Okay, and then we have the multiplication sign of a squared, then the multiplication sign of 10, of positive 10. So multiply it by positive 10. So all we need to do now is multiply the numbers, the 10 times negative 8, that's negative 80, and then put the variables in alphabetical order, a squared, b to the third, a squared, b to the third. So there's your answer. Let's look for that answer on the multiple choice. And when you do look for that answer, you're not going to find it. So the correct answer here would be none of these. They're asking us select all geometric sequences. So you're going to need a calculator handy, because the only way to find out if this is geometric is that it has to have a common ratio. So on the calculator, I would do 1 over 24 divided by negative 1/6. Or by hand, 1 over 24 times the reciprocal negative 6 over 1. And when you do that, I could clearly see that the 6 and the 24, that reduces down. 6 divided by 6 is 1, 24 divided by 6 is 4. So we end up with a negative 1/4 as the common ratio, perhaps. But let's see if it really is common. If I go negative 1/6 divided by negative 2/3, negative 1/6 divided by negative 2/3, that's really negative 1/6 times negative 3/2. Just flip the fraction, it's still negative. And then do the math. The 3 divided by 3 is 1, 6 divided by 3 is 2. And we have a negative times a negative, that would be a positive 1 over 4. Positive 1/4, and that is different, so it did not work. So this first one is not a geometric sequence. There has to be a common ratio between all of your terms in order for it to be geometric. If you did negative 4 divided by negative 2, that's positive 2, but negative 6 divided by negative 4, that's not positive 2, so that's definitely not geometric either. That's technically arithmetic, right? There's a common difference, but no common ratio. Right here, let's check 36 divided by negative 48. And you know what? I want to do this one on the calculator. 36 divided by negative 48. 36 divided by negative 48. That gives us negative 0.75 on the calculator, negative 0.75. But now let me also do the negative 27 divided by 36. Negative 27 divided by 36 on the calculator is the same thing, negative 0.75. So this one does have a common ratio. It is negative 0.75, or you could think of it as negative 3/4. Either way, this one is geometric because it does have the common ratio of negative 0.75 or negative 3/4. Moving on to this last one, on a calculator, I'm going to, so I typed it in the calculator. Notice I used parentheses here. I did parenthesis negative 32 divided by 3, close parenthesis, and then divided that by 16. It gave me this decimal. So maybe the common ratio is negative 0.666, and it continues. Let's see if that's true when I do 16 divided by negative 24. 16 divided by negative 24 on a calculator is the same exact answer. So the common ratio is negative 0.66, and it continues forever. So that makes this a geometric as well. Okay, so obviously none of these is incorrect. It's these two that work. Again, use a calculator. This one divided by that one, see what it equals. This one divided by that one, hopefully it equals the same thing. This one divided by that one, see what it equals. This one divided by that one, it does equal the same thing. So these two are the correct geometric sequences. Which of these following sequences are arithmetic? Well, for arithmetic, you have to have a common difference. So you could use a calculator and do 10/3 take away 2. And again, the Casio does do fractions, but the Texas Instrument doesn't, the one that I have. So use the parentheses button, type in 10/3 minus 2, right? And you'll get the answer 1.33 that it continues to repeat. So do 2 minus 2/3. And as you could see, again, using parentheses, 2 take away parentheses 2/3, it gives you the same exact answer. So you know it has a common ratio of 1.33 that continues forever. So this first one is arithmetic. Okay. So the other ones should be a little easier to do. I don't think we're going to need calculators. Let's see. When I go 6 minus a negative 4, 6 minus a negative 4, that is 10. So maybe the common difference is 10. But when I go negative 4 minus 2, negative 4 minus 2, that's definitely not 10. So I know that this one's not arithmetic. How about this guy? 18 take away 3, that's 15. Okay. 3 take away negative 12. Is it 15? 3 take away negative 12. Change the plus plus. Yes, it is 15. So this one has a common difference of 15, which makes it arithmetic. Last but not least, I guess I will need a calculator right here. 2 take away 15/8. Again, use parentheses. 2 take away parentheses 15 divided by 8 close parentheses, hit equal, you get 0.125. Okay, so maybe that's your common difference, because we are checking for arithmetic after all. Let's do 15/8 take away 7/4 and see if it's the same common difference of 0.125. And as you could see, I did use parentheses. Open up some parentheses. 15 divided by 8 close parentheses, that's a 15/8 minus parentheses 7 divided by 4 close parentheses. It cut it off when I hit equal. But anyways, it's the same exact answer. Common difference is 0.125. So this is arithmetic as well, because there's a common difference of 0.125 in each of the terms. So obviously none of these, no, there's 3 of these 4 were arithmetic, because 3 of the 4 had a common difference. Let's move on. They're giving us some information here, a sub 1, and also the common ratio, which is 3/4, and they're asking us to find the sum of an infinite geometric series. So we know we're going to use the formula for the sum of an infinite geometric series, which is the fraction a sub 1 over 1 minus the common ratio r. So all it is plugging in your values. You have 12 over 1 minus the common ratio 3/4. Change that 1 to a 4/4. Right? Scratch that out, change to a 4/4. Now you could actually subtract 4 take away 3. That'll give you a 1/4 on the bottom and a 12 up on top. So that's really a 12 divided by 1/4, which is really a 12 times the reciprocal of 1/4, which is 4 over 1, which is just 4. So that's really just 12 times 4, which is 48. Final answer is 48. Type in the 6th row of Pascal's triangle. Let's begin. Make a triangle of ones. So after you make your triangle of ones, you add 1 plus 1, that'll be 2. Then you put your ones on the outside again. And then you simply add 1 plus 2, that's 3. 2 plus 1, that's 3. And of course you put outside ones again. And then you go in and do 1 plus 3, that is a 4. 3 plus 3 is 6. 3 plus 1 is 4. Put ones on the outside again. And then, of course, we go add up those numbers. 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. Put ones on the outside again. And last but not least, I think we're on the 6th row here. 1 plus 5 is 6. 5 plus 10 is 15. 10 plus 10 is 20. 10 plus 5 is 15. We got a 6 with ones on the outside again. Let's verify. The power of 0 will give you 1. Power of 1 gives you that. Power of 2 gives you that. Power of 3 gives you that. Power of 4 gives you that. Power of 5 gives you that. And then the power of 6 gives you that. Now, maybe I shouldn't have said 6th row. Maybe I should say type in the row of Pascal's triangle for the binomial of expansion of the 6th power. Yeah, I think I'll rephrase that. So yeah, this is what you're going to have to type in. So when you actually type it in, it says type in with no spaces, with spaces between your terms. So type in the 1 space 6. So 1 space 6 space 15 space 20 space 15 space 6 space 1. Type in those numbers, hit enter, and you'll be good. If you don't do spaces between all your numbers, it's going to be incorrect. But then again, if you type them all in without spaces, just type it all in, it'll also be an alternative answer, which will be correct. But please put spaces between your terms. Anyways, let's move on. On this question, they want us to find a sub 1, which is the first term of our geometric series. So again, we need to know what a series is. We're going to be adding numbers, and it has to be geometric, which means there's a common ratio. And something very important, it's not infinite. Okay, it's not an infinite geometric series. It just says a geometric series, which you could imply is finite. So let's begin by writing down the summation for a finite geometric series. Summation formula. The S sub n equals, that's going to be a sub 1 up on top minus a sub n times r, all divided by 1 minus r. Okay, now the reason why, there's two formulas to use, but the reason why I'm using this one is because they do provide us a sub n. The other one was a sub 1 minus a sub 1 times r to the n power, but we already know that they give us a sub n. That's why I'm using this one. If they would have said n equals 50, then I would have used the other one, the one that had the r to the n, and I could plug in 50 into the position of n. But anyways, you got to look at what they give you to see which formula you're going to use. So let's plug in everything that we know. We know that the answer, the summation, will be negative 342, equaling a sub 1 you do not know, minus a sub n. A sub n is negative 512. We still need to multiply it by r, which is negative 2. And this is divided by 1 minus r, which is negative 2. So let's work this out. The minus minus changes to plus plus, changes to plus plus. And let's actually multiply the 512 times negative 2, that's going to be 1,024, negative 1,024. So what we have is a sub 1 minus 1,024 divided by 3. And that still equals negative 342. So let's solve for a sub 1. Multiply it by 3. That'll cancel out. Multiply it by 3. The answer is negative 1026. Negative 1026. Equals a sub 1 minus 1,024. So our final step on this problem, whoops, you saw the answer already. Our final step will be to add 1,024, add 1,024. So negative 1,026 plus 1,024, that is a sub 1 equaling negative 2. So a sub 1 equaling negative 2. So they're asking for the answer. The answer is negative 2. You type in negative 2, hit equal, you are done. You found the first term of this series. So the final question is to convert 0.303030, convert that to a fraction when that 30 is what's repeating. So as I mentioned in class, you're going to write the fraction that represents that repeating part, the 30, the 0.30. So because this is in your tenths and this is in your hundredths, give me a second, sorry about that, hundredths, then we could say that this is 30 over 100. 30 over 100. 30 over 100, if you do that on a calculator, it will give you the 0.3, right, or 0.30 technically. So the trick is to subtract 1 from the denominator, and then it'll repeat. So you're going to have 30 over 99. And if you check that on a calculator, 30 divided by 99, it will give you the answer 0.303030, that repeats the 30. Anyway, I hope this helps. Good luck.